Hi guys, Assalamu alaikum. I hope you're all well and having a good day. Your favorite A levels physics instructor Shubra Ahmed is back today again with yet another A levels physics video. Here today I'm going to solve the most recent January 2025 Physics Unit 6 question paper in detail so that you guys can understand each and everything so very easily. So without wasting any more time, let's start solving this paper together. A student investigated the pressure of a fixed volume of air using the apparatus shown. So, what are the apparatus that they have given us? There is basically a glass beaker, and there is water in the glass beaker, and there is also a metal flask, and inside the metal flask, there is a fixed volume of air. Then there is an immersion heater as well connected with electrical connectors. So basically there is an electrical connectors connected with the immersion heater. Alright, so now moving on to the first question, it says the student used the immersion heater to heat the water in the beaker. Alright, so basically the immersion heater has been used to heat the water in the beaker. Identify one health and safety issues and how it should be dealt with. So this is a very common question where it asks about the health and safety issues of this particular immersion heater and how it should be dealt with. So we should also say how they can what they can do in order to deal with it in a much better way. So basically the first thing that comes to my mind is this immersion heater is going to heat the water, right? So basically this immersion heater itself is going to be very hot. Now as it is going to be very hot, so before removing that immersion heater, removing that immersion heater from the beaker, we will have to switch off the immersion heater so that the temperature of the immersion heater gets lowered, right? Now the second thing that comes to my mind is this glass beaker itself is going to be very hot, right? Now if you are going to let's say move this glass beaker from one place to another, you will have to use tongs or insulated gloves so that your hands are not getting burned, right? These are the two very concept very daily to daily life thinking that should come in your mind as soon as you look at this question. So basically this is the 4 points that I've given, though you will require either these 2 points, either these 2 points or these 2 points. I think any of these 2 points, or basically these two or these two, will allow you to get these 2 marks. But still, I have given 4 points so that you guys can go through few more points and understand them in detail, or at least having more number of points in your armory. Now the next question, it says the student determined the temperature theta of the fixed volume of air. So basically he has measured the temperature of the air. All right. Describe an accurate method to determine a single value of theta. So he is asking, this is a very common question again. Now how he can measure the value of theta or a single value of theta accurately? This is the question, right? Now, to be able to measure the value of theta accurately, you will definitely need to use a thermometer, right? To measure the temperature, we need a thermometer. So this is the first point, which will give you the first mark. We will have to say use a thermometer to measure the temperature of the water. Now, we all know that we measure the temperatures using the thermometer, but where the thermometer should be kept is also important, because the question asked us about the accuracy. So to be accurate, the thermometer must be close to the flask. The thermometer must be close to the flask, as it is measuring the temperature of the air. So it should be close to the air. It should be close to the flask. Place the thermometer close to the flask. And another thing that you will have to do is you will have to stir the water. Why we will have to stir the water? So that even distribution of heat is there. Let's say the temperature of the water right here and here is the same. Okay, that's why we'll have to start the water to ensure thermal equilibrium or even distribution of heat, so that the temperature of the water in every position on the beaker is the same. Okay, so basically this is going to be your answer right here. You will say, use a thermometer to measure the temperature of the water, place the thermometer close to the flask, and start the water to ensure even distribution of heat or thermal equilibrium. You can write either of them. Okay, now moving on to this question, the part C, it says the student recorded theta or the temperature at a pressure of 110 kilopascal. He repeated the measurements several times as the flask was cooled and reheated. Alright, determine the mean value of theta. Now to calculate the mean, we know we will have to add all of these four values. We will add all of these four values and then divide by the number of values. So we will divide it by 4. Right? This is a very easy peasy lemon squeezy question, right? So basically that's how we are going to measure the value of the theta. Basically we are going to add all of these four values and then divide by 4, which will give us a value of 42.25. But make sure to write the formula in 3 significant figure. Why? Because the data is provided were in 3 significant figure. Okay, now the next question, it says determine the percentage uncertainty in the mean value of theta. Remember one thing, when they ask you to figure out the percentage uncertainty, right after asking the question of mean, you will have to understand one thing, that there are 4 data values that they have given, right? There are 4 values that they have given. So basically we will have to use the formula of half range. We know percentage uncertainty is equals to half range divided by average measured value and 100%, right? Percentage uncertainty is equals to half range divided by average measured value into 100%. And how do we figure out the half range? We know half range is equals to maximum minus minimum divided by the 2. Right? This is what the half range is all about. Right? This is what the half range is all about. Now let's do the math together. So basically this is how you guys will have to do this math. Let's keep the answer right here and let's have a look at this answer. You guys can see half range is maximum minus minimum divided by 2, just like the formula that I have written. Now how do we write the maximum minus minimum? Here you can see the maximum was 43.5 and the minimum was 41. That's why 43.5 minus 41 divided by 2 gives us our half range, and we will use this half range divided by the average measured value, which is our mean value 42.3 multiplied by 100. This gives us a value of 2.96. This is going to be our percentage uncertainty value, and here you will have to write your final answer either in 1 significant figure or 2 significant figure. The percentage uncertainty values should always be in 1 significant figure or 2 significant figure. I always tell my students to write the percentage uncertainty in 2 significant figures. Okay, so basically that's why we will write our answer as 3%. Okay, you can write it down as 1 significant figure as well, because the mark scheme allowed 1 significant figure. Now the next question, it says the diameter of the flask was 15 centimeter. All right, determine the number of molecules in the flask. You may assume that the volume of the air is spherical. So as they have said the volume of the air is spherical, we know the volume of a sphere is 4 by 3 pi r cube, right? They have given us the diameter, so we can figure out the volume easily. And here, to figure out the number of air molecules, we know there is only one formula which relates the number of air molecules, that is PV is equals to NKT. We know the pressure previously, right? They have given us the pressure 110 kilopascal. They have given us the pressure previously. We will figure out the volume from here. N is something that we will have to figure out. K is a constant, and T is the temperature that we have figured out previously, which was 42.3 degrees Celsius, which needs to be converted into Kelvin by adding 273. So basically this is how we will actually construct our answer. Now let's have a look at how they have done it. Here you guys can see we have added 273 to the degree Celsius to convert it into Kelvin. Okay, now the next part, we have calculated 4 by 3 pi r cube. We have converted this 15 first into meter and then into radius, dividing by 2. So basically 15 into 10 to the power minus 2 divided by 2. This is going to be our radius. Okay, this is going to be our radius right here. Let me bring it right here. This is going to be our radius. So this is how we have got our V. And if you make n the subject, it becomes PV by kT, right? If you make here the n the subject, it becomes PV by kT. So pressure was 110 previously. We have got from here multiplied by volume that we have figured out, divided by the K, which is a constant, and the temperature that we have converted into Kelvin. So that's how we are going to do this math, which is going to give us a value of 4.47 into 10 to the power 22. Okay, and this answer can also be given in 2 or 3 significant figures. So we will write our answer as 4.5 into 10 to the power 22. It's better to give it in 2 significant figures because the data provided was in 2 significant figure. So I will write my final answer as 4.5 into 10 to the power 22. Now let's move on to the question number 2. Now in the question number 2, it says a student investigated how varying the power input P to a 12-volt filament bulb affected the brightness of the filament bulb. Complete the circuit diagram for the circuit the student could use in this investigation. Now this is a very easy question because it says you are going to vary your power input. So to vary the power input, we'll have to vary the current. And how we will vary the current? We will vary the current, we will have to use a variable resistor. Okay, as the resistance of the resistor changes, the current in the circuit will change. And then we'll also have to understand how the filament bulb is how the brightness of the filament bulb is affected. So to understand how the brightness of the filament bulb is affected, we'll have to have a voltmeter across the bulb. So now let's draw this one. So this is basically how it will be. Here we will have a variable resistor. When the resistance will decrease or increase, according to that the current will vary. So they have asked to vary the power input. So to vary the power input, we will vary the current actually, because we know power is equals to voltage into current. If the current varies, the power input will also vary. And they have asked how it will affect the brightness of the filament bulb. So to understand or to figure out how the brightness is affected, we'll have to connect a voltmeter across the filament bulb. And as usual, there is always an ammeter in the circuit. So that's how you'll have to construct this. Now in the part B of the question number 2, the student placed a light sensor at a distance from the filament bulb. So basically the light sensor was at a distance from the filament bulb. The light sensor measured X, the light received in lux from the filament bulb. Okay, she predicted that the relationship between P and X is given by P is equals to Kx to the power of 4, where K is a constant. Devise a method to test this prediction. Alright, you should include the use of a suitable graph. Now this type of questions are extremely common, where they ask us to devise a method to test this prediction, and when they mention about the suitable graph, we will actually have to convert them. Okay, we will actually have to convert them into y is equals to mx plus c equation. So we'll have to log them. So log p is equals to log k plus log x to the power of 4, which can also be written as log p is equals to 4 log x plus log k. So this is my y is equals to mx plus c, right? Mx plus c. And here my x coordinate is going to be log x and my y coordinate is going to be log y, and gradient is going to be 4. This is the way you will have to write this part at first, and then later on let's devise the method to test this prediction. Now to devise the method, actually we will have to make sure one thing. The thing is the distance between the filament bulb and the light sensor should be kept constant. And the reason behind keeping the distance between the filament bulb and the light sensor constant is because this P basically means actually the power input. This is my power input, and basically this x is my intensity. This x is my intensity. So basically, by looking at the power input, how much power has been given, we are actually looking at the intensity. So basically we know intensity is equals to power divided by 4 pi r squared. So to be able to see how the intensity changes when the power input is changed, we'll have to keep this distance constant. We'll have to actually keep one constant. We'll have to actually keep one quantity constant to look at how basically the intensity changes when the power is varied, right? This is the main concept. So to look at this, we'll have to keep basically we'll have to ensure the distance between the light sensor and the filament bulb remains constant. Now the second thing is, to be able to measure this power intensity accurately, we'll have to make sure that in that particular room where investigation is carried out, there is no other light rather than the light from the filament bulb. So you have to make sure that there is no background light. Okay. Now the third thing, that is the most important part I believe, is we'll have to calculate this power input first. So basically we'll have to watch how this intensity varies with the power input. So to watch how the intensity varies, we'll have to know the power input. So to calculate the power input, we know power is equals to current into voltage. So we'll have to record current into voltage and then calculate the power input. Now we have calculated the power input. Now basically we will vary the resistance. Okay, we will vary the resistance. When we will vary the resistance, the current in the circuit will vary, the things that we have seen in the previous part of this question as well. So basically then we will record at least 5 sets of intensity values for different 5 sets of power input. Okay, for 5 different sets of power input, how the intensity changes, we will calculate that particular thing, and then we will draw a graph where log p will be my y-axis, log x will be my x-axis, and then we will see whether it is a straight line or not. Now let's have a look at the answer, how we will actually have to construct this answer. The first line is going to be ensure the distance between the light sensor and the filament bulb remains constant, so that when you are looking after how the intensity changes by varying the power input, we'll have to make sure the radius is kept constant, or the distance is kept constant. We'll have to remove the background light, so that's why, so that the intensity value that we get is not altered. It is actually the intensity of the light bulb. We will calculate the power. Before calculating the power, we'll have to record the current and potential difference every time we are varying the power input by varying the resistance, because varying the resistance makes the current vary. So when the current varies, the power input also varies, and we will actually record at least 5 sets of x for 5 different values of p. Okay, for 5 different values of power input, how the intensity actually changes, this is what we'll have to actually record, and then we will draw a graph of p against x to the power of 4 and check if it is a straight line. We can, rather than p against x to the power of 4, you can write, we will plot a graph of log p against log x to check if it is a straight line. It will be okay as well. So make sure you are doing it like that. A student investigated the damped oscillations of a pendulum using the apparatus shown. The paper cone acted as a damper. The student displaced the cone and allowed the pendulum to oscillate. He measured the amplitude every 5 oscillations and recorded the value to the nearest 5 millimeter. Give 2 reasons why it would not be appropriate to record A to the nearest millimeter. Now this question was one of those questions in which in Jan 2025 a lot of students faced the issue, this particular 2 marks question. Now this 2 marks question is relatable to the specimen paper, the paper that is available widely in the internet. You guys can go through this paper. Now this question was more or less common, or this question actually matched with the question that you guys have seen previously. Now it says the student recorded age as 885 millimeter. He recorded the time t for the weight to fall through h and repeated this several times. His measurements are shown below. So basically all the measurements you can see is in three significant figure, but the mean value that they have calculated is in two significant figure. The mean t has been recorded to two significant figures. Explain why this is appropriate number of significant figures in this case. Now why this is actually appropriate to figuring out the mean value in two significant figure, because in this value we know actually that the uncertain value on 2.94 is this 4. This 4 is going to be my uncertain value, right? Either it will be 2.95, 96, 97, or let's say 2.91. So basically it is going to be, if we take it as 2.9, now this 2.9 is more accurate actually. This is going to be more accurate no matter how much uncertainty this value has. 2.9 is going to be the same because the uncertainty relies on this 4 or this 6, right? The uncertainty relies on this particular point. That's why we are going to take it in two significant figures, and it is actually appropriate to take the mean value in two significant figures. Now let's have a look at this answer. Okay, we know the resolution of the stopwatch is 0.01. As it has a resolution of 0.01 seconds, we can say the uncertainty will lie in this last digit, right? So that's why we're going to take it in two significant figure. But there is a human reaction time when starting and stopping the stopwatch. That's why we're going to take it as two significant figure to actually minimize or actually to get relief from that reaction time or that uncertainty or that error. That's why we're taking this as two significant figure. Now why I'm actually showing this question is because this question is actually relating with the Jan 2025 paper. It says given two reasons why it would not be appropriate to record A to the nearest millimeter. Now this is quite relatable to the question that we have seen just now. So why it would not be appropriate to record A to the nearest millimeter. So now let's relate it with meter. If we take it as meter, it will be more relatable. So 5 millimeters can be taken as 0.005 meters, right? 0.005 meters. Now here are a lot of decimal places, right? There are a lot of decimal places. Why it is not appropriate to take a lot of decimal places? It is because here you can see it is a pendulum bob which is right here, and to be able to measure the A, the first thing that we'll have to make sure is that it is very difficult to take this maximum displacement, right? This is very difficult to measure this maximum displacement because the paper cone, when it will actually come to this line, it is very difficult to judge the exact moment the maximum displacement is reached. You might make an error right here to judge it, right? And as the meter rule is like this, okay, it is also difficult to ensure that your line of sight is perpendicular to the scale. Your line of sight is also perpendicular to the scale is also very difficult to actually make sure. And why it is difficult to judge the exact moment the maximum displacement is reached? Because this paper cone will be moving with a very high velocity, right? It will be moving very quickly. So when it will be moving very quickly, with your eyes it is very difficult when it has reached the maximum displacement, and at exactly that time making sure to measure the amplitude is very difficult. So basically in this whole scenario there is a very high uncertainty, and in experiments where there is a very high uncertainties, it is better to take your measurements with less decimal places, so it reduces the uncertainty. So that's why we can write our answers like this, that it is difficult to judge the exact moment the maximum displacement is reached. It is difficult to ensure the light of sight is perpendicular to the scale. That's why the uncertainty will be very high, and when the uncertainty is very high in such experiments, taking small decimal places or less decimal places is better. So it would be actually appropriate it would not be actually appropriate to record a to the nearest millimeters, as the nearest 5 millimeter also means, let's say, 0.00545152. So basically taking this nearest millimeters is inappropriate, because taking as less decimal places as possible is better in such investigations or experiments where there is a very high uncertainty. Okay, so that's why taking the measurements of amplitude into nearest 5 millimeter will not be appropriate. In the part B of question number 3, it says the relationship between A and the number of oscillation n is A is equals to A naught e to the power of minus lambda n, where A naught is the initial amplitude and lambda is a constant. Explain how a graph of ln A against n can be used to determine the value of lambda. So basically this is exactly a very common question where we'll actually have to convert this into y is equals to mx plus c. We'll have to compare it with y is equals to mx plus c. So if you write ln A is equals to ln A naught plus ln e to the power of minus lambda n, okay, we know ln e is nothing, it will go out, so it will become ln A is equals to ln A naught minus lambda n, right? And we can also write it like this: ln A is equals to minus lambda n plus ln A naught, so which can be compared with y is equals to mx plus c. So basically this minus lambda is going to be my gradient, sorry, yes, this is going to be my gradient, and this particular n is going to be my x-axis, and this ln A naught is my y-intercept, and this ln A is my y-axis, right? So basically it was saying how it can be used to determine the value of lambda. So basically we can write that gradient is equals to minus lambda, right? We can here write gradient is equals to minus lambda. Okay, so basically we can use this to figure out the value of lambda. We can actually figure out the gradient, or we can say lambda is equals to negative gradient. Okay, I hope you guys have understood this part. Now let's move on to the next part of this question. It says the student recorded the following results. They have given us this: plot a graph of ln A against n on the grid opposite. So basically we will have to draw a graph of ln A against n. So basically n is right here, but we'll have to put a ln A, right? So let's write ln A. Never ever forget to write this unit. If you forget, we'll lose 1 mark. So make sure you are writing this unit, A in centimeter. So ln A in centimeter. Now there are some very important rules of graphs. I will put that video in the description box, where I've discussed each and everything that you will have to cover in graphs, okay, which is basically the common thing for both physics unit 3 and physics unit 6. I did made that video for physics unit 3 students, but it will be of need to the physics unit 6 candidates as well, because the graphs are more or less the same thing. It is absolutely the same thing. This 5 marks is absolutely the same for both physics unit 3 and 6. So I will put that video in the description box. Okay, now let's figure out this ln A value into your calculator. So if you write ln 8.5, the calculator actually gives me the value as 2.140, but I will write it down in 3 significant figure. Okay, I will write it down as 2.14. Now when I put 7, it gives me a value of 1.946. So to write this into 3 significant figure, I will write it down as 1.95, because all the values needs to be in the same significant figures, and the most preferable one is the 3 significant figure or 2 decimal place. So it will be 1.70, it will be 1.61, it will be 1.39, and it will be 1.25. So as I have got my ln A values and my n values as well, now let's draw the graph right there. This is going to be my y-axis, and this is going to be my x-axis. determine the value of lambda from the graph. This is something that we will do after drawing the graph, because lambda is the gradient. Right, now let's draw the graph. Now in terms of drawing the graph, make sure your scaling is perfect. Your scaling should be in an increments of 1, 2 and 5. This is something that I've explained in that video as well. Please go through that video to understand why we will have to take the increments as 1 to 5 and how we will actually do it. You can also go through my October 2024 physics unit 6 video as well. You will understand that particular part right there as well. So now let's start plotting this graph. Now it starts with 5 and ends at 30 in the x-axis. Right, it ends at 30 in the x-axis. So basically we can take the scaling to 5. Okay, because there are around 1, 2, 3, 4, 5, 6, 7, 8 boxes. So basically if I take from 5 to 30 with an increment of 5, I will require around 6 boxes. So it includes more than 66% of the graph, right? More than 2/3 of the graph. So it's completely all right. Now to take the increments of the y-axis, we'll have to do another thing. That is, it starts in the lowest value is 1.25 and the biggest value is 2.14. Okay, so basically we can say there is a difference of 0.90. There's a difference of 0.90. It starts from 1.2 and ends at 2.14. And how many boxes are there in the y-axis? There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. As there are 13 boxes, we can actually take 0.1 changes in one box. We'll take 0.1 increments in every box. So it will require me 9 boxes. As there are 13 boxes, if I fill up 9 of the boxes, then I'll be done with working with more than 2/3 of the graph paper, right? As the examiners want us to draw our graph within more than 2/3 of the graph. Our drawn graph should be used our drawn graph should use more than 2/3 of this graph provided. So let's draw it like this. Now we can actually draw the first line right here, which will be like this, and then let's draw the x-axis right here. So basically this is first of all going to be my 0 in the x-axis, and we know it starts from 5 and ends at 30. So we'll take an increment of 5. So it will be 5, it will be 10, it will be 15, it is going to be 20, 25, 30, and it is going to be my 35. Right, that's how we are going to work with it. We can write this down as 40. Now let's draw the y-axis. It starts from 1.2 and we'll take an increment of 0.1. So basically 1.2, 1.3 like this. So basically this is going to be my this is going to be my 1.2, and this is going to be my 1.3, this is 1.4, this is 1.5, this is 1.6, 1.7, 1.8, 1.9, 2, 2.1, 2.2, 2.3, and my 2.4. Now here is a very important thing that you should do right before drawing this. The thing is, we'll have to write your y-axis and x-axis along with this unit. So basically my y-axis is ln A per centimeter. So I will have to write it right here. I will have to write that right here. Okay, I can write it like this. I can also actually write it right here. It will be ln A in centimeter. Okay, and then the x-axis is n, right? We'll have to write both of them. Make sure you're writing both of them. Now here for 5 it's 2.14. For 5 it's 2.14. So basically my 5 is here and 2.14 is going to be somewhere right here. So this 5 and 2.14. Now the next point is 10 and 1.95. So basically this is my 10 and 1.95 is going to be like this. 1.95 is going to be somewhere right here. And the next point is 15 and 1.7. So 15 is this and 1.7 is going to be exactly right here. So basically let's draw it more accurately. 15 and 1.7. Oh, this is not correct as well. Oh no, this is my 15 and 1.7. The next part is 20 and 1.61. So 20 and 1.61 is going to be somewhere right here. 20 and 1.61 is going to be somewhere right here. The next part is 25 and 1.39. So 25 and 1.39. So this is 25 and 1.39 is going to be somewhere right here. And the next part is 30 and 1.25. So basically this is my 30 and 1.25 is going to be somewhere right here. So we are done with writing all of them. Now let's join them together. Okay, now let's join them together. So basically to join them together, we will definitely use a scale, and never ever forget to take your scale in the exam hall. Okay, never ever forget that thing, because forgetting that thing will make you lose a lot of marks. So now let's draw this down. This is how we're going to draw it. So this is basically how we're going to draw this graph, and make sure the number of crosses above and below the line is the same. You guys can see here the number of crosses above and below the line is the same in this line of best fit for me, right? So make sure your line of make sure the number of crosses above and below the line is the same, as there is 2 above and 2 below for me right here. So basically we are done with drawing this graph. Now let's move on to this question. It says determine the value of lambda from the graph, and we know lambda is going to be my negative gradient. So basically we'll have to figure out the gradient first. Okay, we'll have to actually figure out the gradient first. So now let's have a look at this gradient from where we will actually start. We can actually go through this. Just give me a minute. Let me think from where we can make sure that the gradient is a bigger triangle. Make sure to take a large triangle. Okay, because in the examiner's report as well and in the mark schemes, they have asked us to use bigger triangles. So make sure you are using bigger triangles. Okay. Now let's actually draw the triangle. We can actually take it we can actually take it from here and then extend it till not like this actually. So from here it can be up to this, and then we can connect it like this. Okay, so this is the triangle that we can take. Now here we guys can see one thing. It is going to be 2.5, sorry, not 2.5 actually. This is going to be 2.0. It is going to be actually 2.07. Okay, this is going to be actually 2.07, and if this is 2.07, this part is actually 1.2, 1.21, 22, and 223. So it is going to be 1.23. So these are the two y values, 2.07 and 1.23. Now let's take this corresponding x values. So the corresponding x values right here is going to be 7. It is going to be not 7 actually, 6, 7, 8. It is going to be 8. It is going to be 8, and let's take the corresponding x value for this part, which is going to be exactly 30. Okay, so now let's write gradient m is equals to y2 minus y1 divided by x2 minus x1. We know our y2 value is 2.07 minus 1.23, which is my y1 value, divided by sorry, this is my 8 minus 30, right? So now let's use the calculator to calculate the gradient. So this gives a value of minus 0.038. It gives us a value of minus 0.038. So we know lambda was negative gradient right here, right? So we can say lambda is going to be equal to 0.038, and the mark scheme allows any answer from 0.035 to 0.038. So basically our answer is within the range. So we can say lambda is equals to 0.038. Right, that's how you are going to use the graph to calculate the gradient. Now in the next part of the question, it says determine the value of a naught from the graph. They have asked us to calculate the value of a naught, and now let's go through the equation and see what was the ln a naught. We can see a naught was actually the y-intercept. A naught is actually the y-intercept. Now let's figure out the y-intercept. To get the y-intercept, we'll actually have to extend this graph a little bit. Okay, we'll have to actually extend this graph a little bit. So it will give us a value of let's look at this, just give me 1 minute. Let's actually extend it accurately. So after extending, we can see our y-intercept is at 2.3, right? Our y-intercept is at 2.3. Now our y-intercept was ln a naught, but the question said to figure out the a naught. So we'll write ln a naught is equals to y-intercept is equals to 2.3. So a naught is equals to, we know when we take ln in the other side, it becomes e to the power of 2.3, which will give us a value of 9.93, which can be written into significant figures as 9.9. Right, this is going to be our final answer. Now in the next question, it says explain why the value of a naught determined from the graph may not be the true value of a naught. Now this was another different question which is not very common in the past couple of years. To solve this type of questions, you should always um, go back to the graph that you have drawn. Now here you guys can see there is a lot of scatter in the diagram. Basically, the line of best fit didn't pass through all the lines. There were a lot of lines which are not in the line of best fit. So we can say as there is a very huge amount of, or you can say there are a lot of scatter in the diagram, we can say that maybe the line of best fit is not accurate. And if the line of best fit is not accurate, then the value of a not determined from the graph will not be the true a naught value, right? So we can write it down like this, that there is significant scatter in the data. Sorry, therefore the best fit line is uncertain. Now let's move on to the question number 4. Are you still stuck in chapter 1? Well, your exams are racing closer. You have watched thousands of videos on YouTube, but your marks are not moving. It's not you, it's the method. Let's fix it. Welcome to Exam Essentials, where every second counts and every session hits. You have seen our question solving walkthroughs, right? Now it's time to go all in. We offer 2 signature courses for A level and O level students. The first one is the high impact crash course, which is basically launched 5 to 6 months before every exam session. Whether it's May 26, October 26, or any future sessions, this course is your fast track to results. For the upcoming October 25 and the January 2026 sessions, our high impact crash course will be starting from June 1. So book your seats as soon as possible. Now, the second course that we always offer is the complete 1-year course designed for students preparing for May 26, October 26, January 2027, and beyond. To know more, check the description box or message us directly on WhatsApp or on our Facebook page, Exam Essentials. Stop struggling, start scoring. You have seen us on YouTube. Now it's time the world sees you succeed. Your top grade is waiting. Let's go get it together. Now, this question in the Jan 2025 paper was exactly the same as the Jan 2024. It says the student set up a ramp as shown. The student placed 2 marker at distance as apart on the ramp. The student used a meter rule to measure the height h and h2, h1 and h2. She calculated the difference in height as this much. Explain why it was appropriate to record the uncertainty in del h as 1 millimeter. Now we know the resolution of meter rule. To calculate this h, the student was definitely using a meter rule, right? And we know the resolution of meter rule is 1 millimeter, and we know they're asking about the uncertainty. Okay, uncertainty is the half resolution. So half resolution means it is going to be 0.5 millimeter. I mean 1 divided by 2. Half of the resolution, 1 divided by 2 is equals to actually 0.5 millimeter. Now this del h is going to have 0.5 millimeter half resolution, and del h2 is going to have 0.5 millimeter half resolution. Now to figure out this del h, we know del h is equals to h1 minus h2, right? Here they are actually subtracted. The measured values are going to be subtracted, but we know that the uncertainty values are always going to be added. So it will become 0.5 millimeter plus 0.5 millimeter, which will give us a value of 1 millimeter. Now let's look at how the answers are going to be for this question. You will have to write the answer basically in this way. We know that the resolution of the meter rule is actually 1 millimeter. The uncertainty in a single measurement is half the resolution, so it is 0.5 millimeter, right? And as measurements are subtracted, the uncertainties are added. So that means 0.5 millimeter plus 0.5 millimeter for both h1 and h2 gives us a complete uncertainty of 1 millimeter. This was exactly the same question which was repeated in the Jan 2024 paper. In part B, it says the student placed a small glass sphere at marker 1. She released the sphere and used a stopwatch to measure the time t for the sphere to reach marker 2. She repeated this several times. The student moved marker 2 to the lower end of the ramp and repeated the procedure. So when you are moving the marker 2 to the lower end, if you move this marker 2 to the lower end, you are basically increasing this s, right? And if you are increasing the distance it will cover, you are also increasing the time it takes for the sphere to fall, right? You are increasing the time as well. Discuss how moving marker 2 to the lower end of the ramp could affect the percentage uncertainty. So basically, as you are increasing the time value, I mean the measured value, we know percentage uncertainty is equals to uncertainty divided by the average measured value. The uncertainty is going to be the constant. As you are taking for a greater value of s, now it will take greater time for the sphere to fall. So we can say the average measured value of the time will be greater. So as the average measured value of the time is greater, the percentage uncertainty is going to be smaller. This is one very easy concept that is also even asked in physics unit 3, and you guys should be able to answer it very easily. It says moving marker 2 increases s, so the value of t also increases. The absolute uncertainty remains constant. Therefore, the percentage uncertainty decreases as the percentage uncertainty and the average measured value is inversely proportional. Now moving on to the next question, it says the time t is related to the acceleration due to gravity by the formula. Determine the student's value of g. So basically to figure out the value of g, we will have to make g the subject. It will become g is equals to 14s squared divided by t squared into 5 into del h, right? So we'll just have to give the value of s, the h and t right here. You will get the value. It's a very easy peasy lemon squeezy 2 marks. So that is how you are going to actually do this question, which says like this. So 14 into s squared, this 90 centimeters squared. Actually we'll have to convert them into meter. We'll have to make this millimeter into meter as well. Okay, make sure all the units are in the same form. So make sure all of them are in meters. As the time is in seconds, you have to convert all other units into meters. So 90 centimeter means 90 into 10 to the power 2 meter. 21 millimeter means 21 into 10 to the power minus 3 meter. Because in order to convert millimeter into meter, you will have to divide it by 1000. This will give us a value of 9.57 meter per second squared. You can give your answer either in 2 significant figure or 3 significant figure. That is not an issue. Basically it's better to give it in 3 significant figure because the most data is provided in the graph in the question is in 3 significant figures. So you can give it in 9.57 meter per second squared. But in the mark scheme they have allowed both 2 significant figure and 3 significant figure. Now the next question, this is a very common question. It says show that the percentage uncertainty in the student's value of g is about 7%. So basically we'll have to show that. Okay, so the percentage uncertainty in the value of the g. So basically g is going to be my subject. So here we can see 14 into s squared, and we know in the percentage uncertainty we are not going to take the constants into consideration. So we'll remove these constants. So we are only left with s squared. So as there is s squared, we know the power needs to be multiplied. So we'll multiply percentage uncertainty in g is equals to 2 into percentage uncertainty of s plus 2 into percentage uncertainty of t, because in percentage uncertainty, though the s and t is in division form, we will always add them because the percentage uncertainties needs to be added always. So we'll write 2 into percentage uncertainty of t plus the percentage uncertainty of h, which is this one. This is how we are going to do this question. Okay, and to figure out the percentage uncertainty of s, we can use uncertainty divided by average measured value into 100%. For t, the same uncertainty divided by average measured value into 100%. For h, 1 divided by 21 into 100%. Right, this is going to be our way of doing this question. So now let's have a look at this answer sheet and then actually discuss this together, how it is going to be actually done. You guys can see here they have taken the percentage uncertainty in s separately. For that they have taken this 0.1 centimeter into meter, and this 0 and this 90 centimeter as well in meter. All of them needs to be converted into meter actually. Both of them needs to be in meter, and here both of them needs to be in millimeter. If you are taken in meter, make sure both the numerator and the denominator is the in meters, and if you are taking in millimeter, make sure both the numerator and denominator is in the same units, so the percentage uncertainty will be the same. And then they have figured out the percentage uncertainty in T as well by dividing 0.03 by 3.36. Okay, after figuring out all, we will just multiply we will actually multiply 2 into the percentage uncertainty of S. So 2 into 0.11 plus 2 into the percentage uncertainty of T. So basically 2 into 0.89, and then the percentage uncertainty of H. By adding all of them, we'll get the percentage uncertainty as 6.76, right? This is going to be our percentage uncertainty value, and it is matching with the one they have asked us to show, right? So we can actually write our answer in 2SF, okay, or minimum 2SF, so it is going to be 6.8%. And it is always better to give your answer of percentage uncertainty in 2SF. I always recommend my students to give your percentage uncertainty answer in 2SF. Now the next part, the last part, it says deduce whether the student's value of G is accurate. So basically the student's value of G was actually, the calculated value was 9.57, and we know the actual value. This is the calculated value. This is the calculated value, and we know the actual value of the G is 9.81. So we know to figure out whether it is accurate or not, we will have to use the formula of percentage difference, and the formula of percentage difference is my bad. When we know the formula of percentage difference is actual value minus calculated value divided by actual value. Actual value minus calculated value divided by this actual value into 100%. We have got that it is 2.1%, which is less than our percentage uncertainty value that we have figured out for G. So that's why we can say it is accurate. If our value of the percentage difference was greater than the percentage uncertainty of percentage uncertainty of G, then we could have said it is not accurate. And actual value is 9.81, we all know, and the calculated value that we have calculated right here was 9.57 divided by the actual value into 100%, and we will subtract 9.6 from the actual value, gives us a value of 2.1%. So basically this is the end of the January 2025 Physics Unit 6 paper. If you have your exam in the May 2025 session, I will definitely ask you to go through all the recent papers from Jan 24 to Jan 25 first. And you can check my YouTube channel to get the October 2024 Physics Unit 6 paper. Solve that with me. You will love it. And then revise all the recent papers from Jan 24 to Jan 25. Those should be enough. And never ever forget to solve all the uncertainty questions or percentage uncertainty questions. I mean the question number 4 from the January 2022 to January 2025. And also practice graphs as much as possible, because these are going to be very important, and students make silly mistakes in these two parts, and this uncertainty questions as well as the graphs carry out around 30 marks. So make sure you are scoring 30 out of 30 on those. Just a little bit of practice can make you score full marks in these two questions, and the first and the second question is the most easiest one. So practice more before exam.